Welcome to Math with Mr. J.
In this video, I'm going to cover everything you need to know about multiplying and dividing fractions. I'll cover multiplying and dividing fractions by fractions, fractions and whole numbers, mixed numbers, how to use cross-cancellation, and we will go through lots of examples. Everything is time-stamped and put into chapters, so feel free to jump around. Check the description for the list of chapters and timestamps. We will start with the multiplying fractions section, and then we will move on to the dividing fractions section. We will start with multiplying fractions by fractions. Now, simply put, all we need to do is multiply straight across. So multiply the numerators, the top numbers, and then multiply the denominators, the bottom numbers. Once we multiply, we can simplify if possible. Let's jump into our examples, starting with number 1, where we have 7/9 times 2/3. Let's multiply straight across, starting with the numerators. So the top numbers, 7 times 2 is 14. Now multiply the denominators. 9 times 3 is 27. We end up with 14/27, which is in simplest form. The only common factor between 14 and 27 is 1. So again, this is in simplest form. Final answer, 14/27. Let's move on to number 2, where we have 6/8 times 3/5. Let's multiply straight across, starting with the numerators. We have 6 times 3. That gives us 18. Now for the denominators, we have 8 times 5. That gives us 40. So we end up with 18/40. Now 18/40 can be simplified. The greatest common factor between 18 and 40 is 2. So let's divide both of these by 2 in order to simplify. 18 divided by 2 is 9, and 40 divided by 2 is 20. So we get a final simplified answer of 9/20. The only common factor between 9 and 20 is 1, so we are in simplest form. The final simplified answer, 9/20. There's how to multiply a fraction by a fraction. Let's move on to multiplying whole numbers by fractions. Now we will take a look at how to multiply a whole number by a fraction. Let's jump into our examples, starting with number 1, where we have 7 times 2/3. Now remember, when we multiply fractions, we multiply straight across. So multiply the numerators, the top numbers, and then multiply the denominators, the bottom numbers. Since we have a whole number within this problem, 7, we need to write that whole number in fractional form. That way we have a numerator and a denominator, and we can multiply straight across. So let's write 7 in fractional form. Now, in order to write a whole number in fractional form, all we need to do is put it over 1. We're not changing the value of that whole number. We are just, again, putting it in fractional form. So we're not changing the value of this problem at all. 7 over 1 still has a value of 7. Then we have times 2/3. Now we can multiply straight across. Let's start with the numerators. So the top numbers, 7 times 2 is 14. Now for the denominators, the bottom numbers, 1 times 3 is 3. So we get 14/3, 14/3. Now that is our answer, but it is an improper fraction. So let's convert it to a mixed number. We do that by dividing the numerator by the denominator. So 14 divided by 3. How many whole groups of 3 in 14? Well, 4. That's the whole number part of our mixed number. Now we don't hit 14 exactly. 4 whole groups of 3 gets us to 12. So we have a remainder of 2. That remainder is the numerator of the fractional part of the mixed number. And then we keep the denominator of 3 the same. Always look to see if you can simplify the fractional part of a mixed number. 2/3 is in simplest form. The only common factor between 2 and 3 is 1. So we are done. Final answer, 4 and 2/3. Now, just as a quick recap as far as how we went from 14/3, 14/3, that improper fraction, to the mixed number, again, we divided the numerator, so 14, and we divided by the denominator, 3, so 14 divided by 3. How many whole groups of 3 in 14? Well, 4 whole groups. That's the whole number portion of our mixed number. 4 times 3 is 12. Subtract 14 minus 12 gives us 2. So a remainder of 2. That's the numerator of our fractional part of the mixed number. And then we keep the denominator of 3 the same. So 4 and 2/3. Let's move on to number 2, where we have 12 times 5/6. So let's rewrite 12 in fractional form by putting it over 1 times 5/6. Now we can multiply straight across. Let's start with the numerators. 12 times 5 is 60. Now for the denominators. 1 times 6 is 6. So we get 60/6, or 60/6, and that's our answer, but it's an improper fraction. So let's convert it to a mixed number. Let's divide the numerator, 60, by the denominator, 6. So 60 divided by 6. How many whole groups of 6 in 60? Well, 10. That hits 60 exactly. We don't have a remainder. So this is our final answer. We get a whole number answer. Again, we don't have a remainder there, so our answer is just 10. There's how to multiply a whole number by a fraction. Let's move on to multiplying mixed numbers. Now we will take a look at how to multiply a mixed number by a mixed number. We will go through 2 examples. Let's jump into number 1, where we have 6 and 1/4 times 1 and 2/3. Now remember, when we have a multiplication problem that involves fractions, we can multiply straight across. So we multiply the numerators, the top numbers, and then we multiply the denominators, the bottom numbers. So our first step here is to convert the mixed numbers to improper fractions. That way we just have numerators and denominators, and we can multiply straight across. So let's start by converting 6 and 1/4 to an improper fraction. We do that by starting at the bottom and working our way to the top. We multiply and then add. So we multiply the denominator by the whole number and then add the numerator. So 4 times 6 is 24, plus 1 is 25. That's the numerator of the improper fraction. Then we keep the denominator the same. So that is 4 times, and then we can convert 1 and 2/3 to an improper fraction. So multiply and then add. 3 times 1 is 3, plus 2 is 5. Keep the denominator of 3 the same. Now we just have numerators and denominators, and we can multiply straight across. Let's start with the numerators. So 25 times 5. That gives us 125. Now for the denominators. 4 times 3. That gives us 12. So we end up with 125 over 12, or 125 twelfths, which is our answer, but it's an improper fraction. So let's convert it to a mixed number. We do that by dividing the numerator, 125, by the denominator, 12. So 125 divided by 12. How many whole groups of 12 in 125? Well, 10. And that's the whole number of our mixed number. That gets us to 120. So we have a remainder of 5. We don't hit 125 exactly. That remainder of 5 is the numerator of the fractional part of the mixed number. And then we keep the denominator of 12 the same. And we get 10 and 5/12. We can look to see if we can simplify the fractional part of this mixed number. 5/12 is in simplest form. The only common factor between 5 and 12 is 1. So we are done. 10 and 5/12. Now, just for a quick recap, I'm going to write out how we went from that improper fraction of 125/12 to the mixed number of 10 and 5/12. Again, we divide the numerator, so 125, by the denominator, 12. So 125 divided by 12. We can start with 12 divided by 12, which is 1. Multiply 1 times 12 is 12. Subtract 12 minus 12 is 0. And then bring down. Now we repeat, so go back to divide. So we have 5 divided by 12, which we can't do that, so we need a 0 here. 0 times 12 is 0. Subtract 5 minus 0 is 5. So 10, remainder 5. 10 is the whole number of our mixed number. The remainder of 5 is the numerator, and then we keep the denominator of 12 the same. So again, our final answer, 10 and 5/12. Let's move on to number 2. For number 2, we have 8 and 1/2 times 3 and 7/8. Let's start by converting these mixed numbers to improper fractions. We will do 8 and 1/2 first. So 2 times 8 is 16, plus 1 is 17 over 2, so 17 halves, times, now for 3 and 7/8, so multiply and then add. 8 times 3 is 24, plus 7 is 31. And then we keep the denominator of 8 the same. Now we can multiply straight across, and we will start with the numerators. So 17 times 31. For number 2, this is going to take a little more work than number 1. I'm not sure what 17 times 31 is, so I'm going to go to the side and write this out and multiply. So let's do 31. I'll put the larger number in value on top, times 17. 7 times 1 is 7. 7 times 3 is 21. Now we need a 0, and then we have 1 times 1 is 1, and then 1 times 3 is 3. Add, 7 plus 0 is 7, 1 plus 1 is 2, and then 2 plus 3 is 5. So we get 527 for the numerator, and then as far as the denominators, we have 2 times 8, which is 16. So we end up with 527 over 16, or 527/16. That is our answer, but it's an improper fraction. So let's convert it to a mixed number by dividing the numerator, 527, by the denominator, 16. Now, I'm not sure what that answer is, so again, I'm going to come off to the side and work through that. So 527 divided by 16. So we will start with 52 divided by 16. How many whole groups of 16 in 52? Well, 3. That gets us to 48. Multiply 3 times 16 is 48. 52 minus 48 is 4. Bring down the 7, and now we repeat. So we divide. We have 47 divided by 16. How many whole groups of 16 in 47? Well, 2. That gets us to 32. And now we can multiply. 2 times 16 is 32. Subtract, and we get 15. So 32, remainder 15. That means 32 whole groups of 16 in 527. So that's the whole number of our mixed number. And then we have a remainder of 15, so that's the numerator of the fractional part. And then we keep the denominator of 16 the same. So we get 13 and 15 sixteenths. We can check to see if we can simplify the fractional part of the mixed number. 15 sixteenths is in simplest form. The only common factor between 15 and 16 is 1. So we are done. Final answer, 32 and 15 sixteenths. So there you have it. There's how to multiply a mixed number by a mixed number. Let's move on to multiplying a mixed number by a whole number. Now we will take a look at multiplying a mixed number by a whole number. Let's jump into our example where we have 5 and 5/6 times 3. Now the first thing that we want to do, we want to convert our mixed number to an improper fraction and then write our whole number as an improper fraction. Let's start with the mixed number, and we start at the bottom and work our way up. So we multiply and then add. So we do our denominator times the whole number, so 6 times 5, which is 30, plus the numerator of 5. So 30 plus 5 is 35. That's the numerator of our improper fraction. We keep the denominator of 6 the same. So we get 35 over 6. Now that improper fraction is equivalent to the mixed number. We just converted it to an improper fraction. So we're not changing the value of the problem at all. Now we need to write our 3 as a fraction. So put it into fractional form. And all we need to do to put a whole number in fractional form is put it over 1. We want an improper fraction and the whole number to be in fractional form, so all we have is a top and a bottom. That way we can multiply straight across. So once we're at this point, we can multiply straight across. So numerator times numerator and denominator times denominator. Let's start with the numerators. So 35 times 3. 35 times 3 gives us 105. As far as our denominators, we have 6 times 1, which is 6. So our answer as an improper fraction is 105 sixths, or 105 over 6. Now let's convert that to a mixed number, and we do that by dividing our numerator by the denominator. So 105 divided by 6. I'm going to come to the side here to work through that. So we have 105 divided by 6. The first thing we need to do, we need to find out how many whole groups of 6 are in 105. That's going to be the whole number part of our mixed number. So let's start with 10 divided by 6. How many whole groups of 6 out of 10? Well, 1. 1 times 6 is 6. Subtract. 10 minus 6 is 4. Bring down our 5. So we have 45 divided by 6 now. How many whole groups of 6 out of 45? Well, that's going to be 7. That gets us to 42. So 7 times 6 is 42. Subtract, and we get a remainder of 3. So we do not hit 105 exactly. We have something left over, that remainder 3. So 17 whole groups of 6 out of 105. That's going to be our whole number portion of the mixed number. Now we had a remainder of 3. That's going to be the numerator of the fractional part of our mixed number. And then we keep our denominator of 6 the same. So we get 17 and 3/6. Always check to see if you can simplify the fractional part of a mixed number. And in this case, we can. We have a common factor of 3 between 3 and 6. So let's divide both of these by 3 in order to simplify. And we get 17. 3 divided by 3 is 1. And then 6 divided by 3 is 2. So we get 17 and a half for our final simplified answer. There's how to multiply a mixed number by a whole number. Let's move on to multiplying a mixed number by a fraction. Now we will take a look at multiplying a mixed number by a fraction. Let's jump into our example where we have 4 1/4 times 3/5. Now the first thing that we need to do, we need to convert that mixed number to an improper fraction. That way we just have a numerator and a denominator, a top and a bottom. So we do that by multiplying and then adding. We start at the bottom and work our way to the top. So we multiply, then add. So our denominator times the whole number. 4 times 4 is 16, and then we add the numerator. So 16 plus 1 gives us 17. That's the numerator of our improper fraction, and then we keep the denominator of 4 the same. Bring down our multiplication sign, and then our fraction. At this point, we are ready to multiply, and we multiply straight across when we multiply fractions. So the numerator times numerator, and then denominator times denominator. Let's start with the numerators, the top numbers. So 17 times 3, that gives us 51. Our denominators, the bottom numbers, we have 4 times 5, which gives us 20. So we get to 51/20, and that's our final answer as an improper fraction. Now we can convert that to a mixed number. We do that by dividing. We divide our numerator, 51, by our denominator, 20. So we need to think, how many whole groups of 20 can we pull out of 51? Well, 2. That gets us to 40. Now we do not hit 51 exactly. We have something left over, a remainder. So if we pull 2 whole groups of 20 out of 51, that's pulling 40 out of 51. So we have a remainder of 11. That's the numerator of our mixed number. And we keep our denominator of 20 the same. So to recap, I'm going to write this out off to the side. We did 51 divided by 20. So how many whole groups of 20 out of 51? Well, 2. That's the whole number part of our mixed number. 2 times 20 is 40. So let's subtract to get our remainder. 51 minus 40 is 11. So we get 2, remainder 11. That remainder of 11 is the numerator part of the fractional part of the mixed number, and then we keep our denominator of 20 the same. Always check to see if you can simplify the fractional part of a mixed number. 11/20 is in simplest form. The only common factor between 11 and 20 is 1. So we are done. 4 1/4 times 3/5 equals 2 11/20. There's how to multiply a mixed number by a fraction. Let's move on to how to use cancellation when multiplying fractions. Now we will take a look at using cancellation, also called cross-cancellation, when multiplying two fractions. Cancellation is a way to simplify a problem before we multiply. Now remember, when we multiply fractions, we multiply straight across. So multiply the numerators, the top numbers, and then multiply the denominators, the bottom numbers. We use cancellation before we multiply straight across. This strategy gives us smaller numbers in value to work with and easier numbers to work with. Let's jump into our examples, starting with number 1, where we have 7/10 times 5/6. When we use cancellation, again, we need to look to simplify the problem before we multiply. Look for common factors other than 1 diagonally. That way we can divide those numbers by that common factor in order to simplify the problem before multiplying. Think of it like simplifying fractions, but we are looking diagonally. So let's look at 7 and 6 first. Are there any common factors between 7 and 6 other than 1? No, the only common factor is 1, so we can't use cancellation with the 7 and the 6. Now let's take a look at the 10 and the 5. Are there any common factors other than 1 between 10 and 5? Yes, 5 is a common factor, and it happens to be the greatest common factor. So let's divide 10 and 5 by 5. So 10 divided by 5 gives us 2. 5 divided by 5 gives us 1. Now we have a simpler problem. We have smaller numbers in value to work with. So let's multiply straight across now, starting with the numerators. 7 times 1 is 7. Now for the denominators, 2 times 6 gives us 12. 7/12 is our final answer, and it is in simplest form. The only common factor between 7 and 12 is 1. So we are done. 7/12. Now let's go through that problem without using cancellation in order to see the difference. So we have 7/10 times 5/6. So let's multiply straight across, again without using cancellation. We will start with the numerators. So 7 times 5 is 35. Now for the denominators, 10 times 6 is 60. So we get 35/60ths, which is different than when we used cancellation. Well, 35/60ths isn't in simplest form, so let's simplify. Are there any common factors between 35 and 60 other than 1? Yes, 5, and 5 is the greatest common factor. So let's divide 35 and 60 by 5 in order to simplify. 35 divided by 5 is 7. 60 divided by 5 is 12. So our final simplified answer, 7/12. The only common factor between 7 and 12 is 1, so that is in simplest form, and we are done. So we get 7/12 that way as well. So do we have to use cancellation in order to multiply fractions? No, but it is a good strategy to be familiar with and use when possible. It can be helpful. Let's move on to number 2, where we have 15 22nds times 11/12. Let's look to use cancellation. And again, we look diagonally. So let's take a look at 15 and 12 first. Do we have any common factors other than 1? Yes, 3 is a common factor and the greatest common factor. So let's divide them both by 3. 15 divided by 3 is 5. 12 divided by 3 is 4. Now let's take a look at 22 and 11. Are there any common factors other than 1 between 22 and 11? Yes, 11, and 11 is the greatest common factor. So let's divide 22 by 11. That gives us 2. And then 11 divided by 11, that gives us 1. Now we can multiply straight across, and you can see that we have much simpler and easier numbers to work with when we multiply straight across. So let's start with the numerators. 5 times 1 gives us 5. Now for the denominators, 2 times 4 gives us 8. So we get 5/8. The only common factor between 5 and 8 is 1, so we are in simplest form, and we are done. For number 2, that problem was much simpler to work through after we used cancellation. We had 5 times 1 and 2 times 4 instead of 15 times 11 and 22 times 12. Now, did we have to use cancellation? No, we could have gone straight across and done 15 times 11 and then 22 times 12 and then simplified. But the cancellation made it easier and simpler as far as multiplying straight across. So understanding cancellation and how to use it can be helpful when multiplying fractions. There's how to use cancellation when multiplying two fractions. Let's move on to using cancellation when multiplying mixed numbers. Now we will take a look at using cancellation when multiplying mixed numbers. Let's jump into our example where we have 10 and 1/8 times 4 and 4/9. Now the first thing that we need to do, we need to convert these mixed numbers to improper fractions. That way we just have a numerator and a denominator. We'll start with 10 and 1/8. So let's go from the bottom and work our way to the top. So we multiply and then add. We do our denominator times the whole number. So 8 times 10, which is 80, plus our numerator, which is 1. So 80 plus 1 is 81. That's our numerator of the improper fraction. We keep our denominator of 8 the same. We'll bring our multiplication sign down and then convert our second mixed number. Start at the bottom, we multiply, and then add. So 9 times 4 is 36, plus 4 is 40. So that's our numerator, and we keep our denominator of 9 the same. So we have 81/8 times 40/9. 81/8 is equivalent to 10 and 1/8. It's just in the form of an improper fraction, and then 10 and 1/8 is in the form of a mixed number. Both of those are equivalent. So when we convert to an improper fraction, we're not changing the value of anything. And then 40/9 is equivalent to 4 and 4/9. Again, we did this, so we just have a numerator and a denominator, and we are able to multiply. At this point, we can multiply straight across. So we can do 81 times 40 and then 8 times 9. But we can use cross cancellation, and this is a way to simplify fractions before multiplying. It gives us smaller and easier numbers to work with, therefore a simpler problem to solve. We cross cancel by looking for common factors between the numerators and denominators, so the top and bottom. Think of it as simplifying fractions, but we can look diagonally as well. For example, we have 81 and 9. So 81 right here and 9 diagonally. We can look for common factors there. A common factor between 81 and 9 is 9. So what we can do, we can divide both of those by 9. So let's cross them out and divide them both by 9. 81 divided by 9 is 9. And then 9 divided by 9 is 1. So you can see that gave us some smaller numbers in value and easier numbers to work with. We can also look the other way diagonally. So between 8 and 40, do we have any common factors? Yes. The greatest common factor between 8 and 40 is 8. So let's divide them both by 8. So 8 divided by 8, let's cross it out. That's going to give us 1. And then 40 divided by 8 is 5. Once we get to this point, we can multiply straight across. 9 times 5 is 45. And then 1 times 1 is 1. Now 45 over 1, that equals 45. So let's write our answer as a whole number instead of leaving it as an improper fraction. So our final answer, 45. Now, if we did not use cross cancellation, we would have to multiply 81 times 40 and then 8 times 9 and then simplify from there. And eventually we're going to get the same answer. So cross cancellation is a useful tool when we have multiplication problems that involve fractions. Again, it gives us smaller and easier numbers to work with, therefore a simpler problem to solve. Think of it as simplifying the problem before multiplying. Now, can we use cross cancellation for every single multiplication problem that involves fractions? No, we have to have common factors other than 1 between our numerators and denominators. If the only common factor we have is 1 between our numerators and denominators, we can't use cross cancellation. So something to keep in mind. So there's how to use cancellation when multiplying mixed numbers. Let's move on to multiplying improper fractions. Now we will take a look at how to multiply improper fractions. So, how to work through a multiplication problem involving one or more improper fractions. Now, we go through any problem involving improper fractions the same way we do with proper fractions. Multiply straight across, so numerator times numerator, the top numbers, and then denominator times denominator, the bottom numbers, and then simplify if possible. Improper fractions just have a value greater than one whole. If we're given a problem involving any improper fractions, that doesn't change the way we multiply. Let's jump into our examples, starting with number 1, where we have 8/3 times 1/4. Let's multiply straight across, starting with the numerators. We have 8 times 1, so straight across here. 8 times 1 is 8. Now for the denominators. So 3 times 4 is 12. We end up with 8/12, which is correct, but we can simplify. The greatest common factor between 8 and 12 is 4. Let's divide 8 and 12 by 4. So 8 divided by 4 and 12 divided by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. 2/3 is in simplest form, so this is our final simplified answer, 2/3. Let's move on to number 2, where we have 5/2 times 11/6. Let's multiply straight across, starting with the numerators. 5 times 11 is 55. Now for the denominators. 2 times 6 is 12. So we end up with 55/12, which is an improper fraction. So let's convert this to a mixed number for our final answer. We do that by dividing. So we divide the numerator, 55, by the denominator, 12. So 55 divided by 12. How many whole groups of 12 in 55? Well, 4. That gets us to 48. We don't hit 55 exactly. We have a remainder of 7, and then we keep the denominator of 12 the same. We end up with 4 and 7/12. We can look to see if we can simplify that fractional part of the mixed number. 7/12 is in simplest form. The only common factor between 7 and 12 is 1. So our final answer, 4 and 7/12. Now I do want to review real quick how we went from that improper fraction to a mixed number by writing out all of the steps. So we divided the numerator, 55, by 12. So 55 divided by 12. How many whole groups of 12 in 55? 4. So that's the whole number part of our mixed number. 4 times 12 is 48. 55 minus 48 gives us a remainder of 7. That goes right here. Then we keep the denominator of 12 the same. So we end up with 4 and 7/12. There's how to multiply improper fractions. Let's move on to multiplying improper fractions and whole numbers. Now we will take a look at how to multiply improper fractions and whole numbers. Let's jump into our examples, starting with number 1, where we have 6 times 5/2. Now we need to multiply straight across and simplify if possible. Since we need to multiply straight across, we need to rewrite the whole number in fractional form. That way we have a numerator and denominator, and we can multiply straight across. So let's rewrite that whole number, 6, in fractional form. And we do that by putting it over 1. We can rewrite any whole number in fractional form by putting it over 1. We're not changing the value of that 6. That fraction, 6 over 1, still has a value of 6 times 5/2. Now we can multiply straight across. Since we rewrote that whole number in fractional form, we have a numerator and a denominator. Let's start with the numerators. So 6 times 5 is 30. Now for the denominators, 1 times 2 is 2. So we end up with 30 halves, 30 over 2. But this is an improper fraction. So let's convert this to a mixed number. We do that by dividing the numerator by the denominator. So we have 30 divided by 2. How many whole groups of 2 in 30? Well, 15. And we hit 30 exactly. We do not have a remainder. So this actually works out to be a whole number, not a mixed number. Again, because we don't have a remainder there. So 6 times 5 halves equals 15. Let's move on to number 2, where we have 9/7 times 3. So let's rewrite this with the whole number in fractional form. That way we have a numerator and a denominator, and we can multiply straight across. Let's start with the numerators. 9 times 3 is 27. Now for the denominators, 7 times 1 is 7. So we end up with 27/7, which is an improper fraction. So let's convert this to a mixed number. We divide the numerator by the denominator in order to do that. So 27 divided by 7. How many whole groups of 7 in 27? Well, 3 whole groups. That gets us to 21. So we have a remainder of 6. That's the numerator of our fractional part here. And then we keep the denominator of 7 the same. We can always look to simplify the fractional part of a mixed number. 6/7 is in simplest form. The only common factor between 6 and 7 is 1. So we are done. 3 and 6/7. Now, just for a quick recap as far as how we went from that improper fraction, 27/7, to the mixed number 3 and 6/7, I'll work this out by hand. So we did 27 divided by 7. How many whole groups of 7 in 27? Well, 3 whole groups. That's the whole number part of the mixed number. 3 times 7 is 21. Subtract 27 minus 21 is 6. So we get a remainder of 6. That remainder is the numerator of the fractional part. And then we keep the denominator of 7 the same. So there is the multiplying fractions section. Let's move on to the dividing fractions section. Here is our section on dividing fractions. Let's start by taking a look at dividing fractions by fractions. Now, when working with fractions and division, we need to remember 3 steps: keep, switch, flip. We can also think multiply by the reciprocal. When we flip a fraction, that's called the reciprocal. So this means we're going to use multiplication to solve these. This actually makes the process simpler. Now, how and why this works, that's something I'll cover later in this video. Let's jump into number 1, where we have 3/4 divided by 1/7. So we are seeing how many 1/7 we can make out of 3/4, or how many 1/7 are in 3/4, so to speak. So let's start by rewriting this problem using keep, switch, flip. So we always keep the first fraction or number. So we keep 3/4 as is. We switch to the opposite or inverse of division, which is multiplication. And since we switch to the opposite or inverse of division, we're going to flip the second fraction. So the 7 is going to be our numerator, and the 1 is going to be our denominator. So we end up with 7 over 1. Once we get to this point, it's a multiplying fractions problem. So we can multiply straight across. 3 times 7 is 21. And then 4 times 1 is 4. And we end up with 21/4. Now that's an improper fraction, so we do not want to leave it. We need to divide our numerator of 21 by 4. How many whole groups of 4 are in 21? Well, 5. That gets us to 20. So 5 whole groups of 4, that's our whole number of the mixed number here. Now that doesn't hit 21 exactly. We have a remainder of 1, so that's our numerator in our fractional part of the mixed number, and we keep our denominator of 4 the same. Always look to see if you can simplify the fractional part of a mixed number. 1/4 is in simplest form, so we are done. 5 and 1/4 is our answer for number 1. So 3/4 divided by 1/7 equals 5 and 1/4. Let's move on to number 2, where we have 2/3 divided by 2/5. Keep, switch, flip. So keep 2/3 here. Switch to multiplication, and then flip that second fraction. So 5 over 2. And now we can multiply straight across. 2 times 5 is 10. 3 times 2 is 6. So we get 10/6. So that's an improper fraction. We need to convert to a mixed number. So 10 divided by 6. How many whole groups of 6 out of 10? Well, 1. And we get a remainder of 4. Keep our denominator of 6 the same. We can simplify 4/6. We have a common factor of 2. So let's divide each of these by 2 here. And we get 1 and 2/3. So our answer for number 2 is 1 and 2/3. 2/3 divided by 2/5 equals 1 and 2/3. There's how to divide a fraction by a fraction. Let's move on to dividing a fraction by a whole number. Now we will take a look at dividing a fraction by a whole number. Let's jump into number 1, where we have 1/2 divided by 3. So we are taking 1/2 and dividing it into 3 equal groups or parts. Let's rewrite the problem using keep, switch, flip in order to solve this. So always keep the first fraction or number. So let's rewrite the problem. So 1/2 we are going to keep. Then we switch to the opposite or inverse of division, which is multiplication. And since we switched to multiplication, we need to flip the second number or fraction. In the case of number 1, we have a whole 3 here. So how do we flip this? Well, let's put that whole number over 1. That way we have a numerator and a denominator. That does not change the value of the problem. That still has a value of 3. So now we can flip. So the 1 is going to go up to the top and be our numerator, and the 3 is going to be the denominator. So we flipped that second number. Once we get to this point, we have a multiplying fractions problem. So we can multiply straight across. 1 times 1 is 1, and 2 times 3 is 6. So 1/6 is our final answer. Always check to see if you can simplify. 1/6 is in simplest form, so we are done. 1/2 divided by 3 equals 1/6. Let's move on to number 2, where we have 4/7 divided by 6. Keep, switch, flip. So let's rewrite the problem. Keep 4/7. Switch to multiplication, and then we need to flip. So we can write that 6 in fractional form, and now we can flip. So the 1 is now our numerator, and the 6 is now our denominator. And we can multiply straight across. 4 times 1 is 4. 7 times 6 is 42. So we get 4 over 42, which can be simplified. 4 and 42 have a greatest common factor of 2. So let's divide each of these by 2. And we get 2 over 21 for our final simplified answer. So there's how to divide a fraction by a whole number. Let's move on to dividing a whole number by a fraction. Now we will take a look at dividing a whole number by a fraction. Let's jump into number 1, where we have 2 divided by 1/4. Now we can think of this as how many 1/4 are in 2, or how many 1/4 can we make out of 2? We are dividing 2 by 1/4. Let's rewrite our problem using keep, switch, flip, also known as multiplying by the reciprocal. So we start with keep. We always keep the first number or fraction. In the case of number 1, we have a whole 2. So we need to keep that as 2, but we're going to rewrite it as a fraction. Whenever you rewrite a whole number and put it in fractional form, all you need to do is put it over 1. Now, the purpose of this, we want to have a numerator and a denominator. So we kept the value of 2 there, we just put it in fractional form. Then we switch from division to multiplication. And since we switched to the inverse or opposite of division, we're going to need to flip the second number or fraction. In the case of number 1 here, we have a fraction. So the denominator is now going to be the numerator, and the numerator is now going to be the denominator. So we have 4 over 1. Once we get to this point, we have a multiplying fractions problem, which we just multiply straight across when we multiply fractions. So 2 times 4 is 8, and 1 times 1 is 1. So we get to the answer of 8 over 1, which is an improper fraction, so we do not want to leave it like that. This is going to be 8. Our final answer is 8. 2 divided by 1/4 equals 8. Let's move on to number 2, where we have 7 divided by 2/5. So we are finding out how many 2/5 are in 7, so to speak. So keep, switch, flip. We will keep our 7, but put it in fractional form by putting it over 1, switch to multiplication, and then flip our second number or fraction. Now we can multiply straight across. 7 times 5 is 35, and 1 times 2 equals 2. So our answer is 35 over 2. Now we don't want to leave it improper. We want to convert this to a mixed number. So we do 35 divided by 2. How many whole groups of 2 are in 35? Well, 17. So that's our whole number of our mixed number. Now we didn't hit 35 exactly. We had a remainder of 1. So that's our numerator of the fractional part. And then we keep our denominator of 2 the same. So 17.5. Always look to see if you can simplify the fractional part. 1/2 is in simplest form. So we are done. Our final answer, 17.5. So there's how to divide a whole number by a fraction. Let's move on to dividing a mixed number by a mixed number. Now we will take a look at dividing a mixed number by a mixed number. Let's jump into our example where we have 4 3/4 divided by 2 1/3. Now the first thing that we want to do is to convert these mixed numbers to improper fractions. That way we just have a numerator and a denominator. Let's start with 4 3/4. And we start at the bottom and work our way to the top. So we multiply, then add. So we do 4 times 4, so the denominator times the whole number. 4 times 4 is 16. Then we add the numerator. 16 plus 3 is 19. So 19 is the numerator of our improper fraction. We keep our denominator of 4 the same. Then we can bring our division sign down and convert our second mixed number. So again, we multiply, then add. So 3 times 2 is 6, plus 1 is 7. That's our numerator, and then keep the denominator of 3 the same, so 7/3. 19 fourths is equivalent to 4 3/4, and then 7/3 is equivalent to 2 1/3. So we're not changing the value of the problem at all when we convert to improper fractions. Mixed numbers and improper fractions are equivalent, they're just in different forms. Now again, we're converting to improper fractions, so we just have a numerator and a denominator, and then we can go through our steps for dividing these fractions, which we're going to use keep, switch, flip, also known as keep, change, flip. So no matter how you think of it, they mean the same thing. I know there's different words out there for these steps, but in the end, they all mean the same thing. So let's keep our first fraction here, our first improper fraction, so 19 fourths. Then we switch or change our division to multiplication, and then we flip our second fraction, our second improper fraction here. So the denominator becomes the numerator, and the numerator becomes the denominator. This is called the reciprocal. So we have 3/7. Once we get to this point, we can multiply straight across. So numerator times numerator, and then denominator times denominator. Let's do the numerators first. So 19 times 3, that gives us 57. And then we have 4 times 7, which is 28. Now that's our answer as an improper fraction. We're going to convert it to a mixed number. So we need to do our numerator, 57, divided by our denominator, 28. Now we can do this using mental math, or we can write everything out. Some problems are going to be a little simpler and we're going to be able to use mental math, and in some situations we'll have to write out the problem. I'll go through both here so you can see what that looks like. Let's use mental math here first. So how many whole groups of 28 out of 57? Well, if you're able to think about that, it's going to be 2 whole groups of 28 because that gets us to 56. So 2 whole groups of 28. Now we do not hit 57 exactly. We have something left over, a remainder. So the difference between 57 and 56 is 1. So we have a remainder of 1. And we keep our denominator of 28 the same. Let me write that out as well. So we have 57 divided by 28. So we need to think how many whole groups of 28 out of 57. Well, we said that's 2. That gets us to 56. So 2. 2 times 28 is 56. So we get a remainder of 1. This 2 is going to be the whole number, part of our mixed number, 2 whole 28s out of 57. And then this 1, the remainder, is going to be the numerator. And then we keep our denominator of 28 the same. Once we get to our mixed number, we can check to see if we can simplify the fractional part. 1/28 is in simplest form. The only common factor between 1 and 28 is 1. So we are done. 2 and 1/28. So there's how to divide a mixed number by a mixed number. Let's move on to dividing a mixed number by a whole number. Now let's take a look at dividing a mixed number by a whole number. Let's jump into our example where we have 5 4/9 divided by 3. Now the first thing that we need to do is rewrite everything in fractional form. So we're going to convert everything to improper fractions. That way we just have numerators and denominators. So we can convert 5 4/9 to an improper fraction first. We start at the bottom and multiply and then add. So take the denominator and multiply it by the whole number. So 9 times 5, that gives us 45. And then we add the numerator. So add 4. 45 plus 4 gives us 49. And we keep the denominator of 9 the same, divided by 3. So how do we write 3 in fractional form? Well, we can write any whole number in fractional form by putting it over 1. So now we have 49/9 divided by 3 over 1. Now let's keep, switch, flip. So keep 49 ninths, switch to multiplication, and then flip 3 over 1. So 1 is now the numerator, and 3 is now the denominator. So 49 ninths times 1/3. Let's multiply straight across, starting with the numerators. So 49 times 1 gives us 49. Now for the denominators, 9 times 3 gives us 27. So we end up with 49/27, which is our answer, but it's an improper fraction. So let's convert it to a mixed number. We do that by dividing the numerator, 49, by the denominator, 27. So 49 divided by 27. How many whole groups of 27 in 49? Well, 1. Now we don't hit 49 exactly. We have a remainder of 22. That is the numerator of the fractional part of the mixed number. And then we keep the denominator of 27 the same. So we end up with 1 and 22/27. We can always look to see if we can simplify the fractional part of a mixed number. The only common factor between 22 and 27 is 1. So that is in simplest form. We are done. 1 and 22/27. Just for a quick recap, I'm going to write out how we went from that improper fraction of 49/27 to the mixed number of 1 and 22/27. So we divided the numerator, 49, by the denominator, 27. So 49 divided by 27. How many whole groups of 27 in 49? Well, 1. That is the whole number of our mixed number. 1 times 27 is 27. Subtract. So 49 minus 27. 9 minus 7 is 2. 4 minus 2 is 2 as well. So we get a remainder of 22. That is the numerator of the fractional part of the mixed number. And then we keep the denominator of 27 the same. So 1 and 22/27. So there's how to divide a mixed number by a whole number. Let's move on to dividing a whole number by a mixed number. Now let's take a look at dividing a whole number by a mixed number. Let's jump into our example where we have 10 divided by 4.5. Now, the first thing that we need to do is rewrite this problem with everything in fractional form. So everything rewritten as an improper fraction. That way, we just have numerators and denominators, and we can go through our steps. Keep, switch, flip. So let's start by rewriting 10 in fractional form as an improper fraction. And we do that by putting it over 1. Remember, we can rewrite any whole number in fractional form by putting it over 1. Divided by, and then as far as 4.5, we need to convert that to an improper fraction by working our way up from the bottom. So start at the bottom and work our way up. We multiply and then add. So multiply the denominator by the whole number. So 2 times 4 is 8. And then add the numerator. 8 plus 1 is 9. That's the numerator of our improper fraction. And then keep the denominator of 2 the same. So we have 10 over 1 divided by 9 over 2. Now we just have numerators and denominators, and we are able to keep, switch, flip. So let's work through our steps. We keep 10 over 1, switch to multiplication, and then flip 9 over 2. So 2 is now the numerator, and 9 is now the denominator. Now we can multiply straight across. Let's start with the numerators. 10 times 2 is 20. Now for the denominators. 1 times 9 is 9. So we end up with 29ths, which is our answer, but it's an improper fraction. So let's convert it to a mixed number by dividing the numerator, 20, by the denominator, 9. So we have 20 divided by 9. How many whole groups of 9 in 20? Well, 2 whole groups of 9 in 20. That's the whole number of our mixed number. Now we don't hit 20 exactly. 2 whole groups of 9 gets us to 18. So we have a remainder of 2. That is the numerator of the fractional part of the mixed number. And then we keep the denominator of 9 the same. So we end up with 2 and 2/9. We can always look to see if we can simplify the fractional part of a mixed number. The only common factor between 2 and 9 is 1, so this is in simplest form, and we are done. 2 and 2/9. Now I do want to go through a quick recap as far as how we went from that improper fraction of 20/9 to the mixed number of 2 and 2/9. So again, we divided the numerator, 20. So I'm going to write this out off to the side here. So numerator 20 divided by the denominator, 9. So how many whole groups of 9 in 20? 20 divided by 9. Well, 2. And that 2 is the whole number of the mixed number. Now we multiply. 2 times 9 is 18. Subtract. 20 minus 18 is 2. So we get a remainder of 2. That remainder is the numerator of the fractional part of the mixed number. And then we keep the denominator of 9 the same. So there's how to divide a whole number by a mixed number. Let's move on to dividing a mixed number by a fraction. Now let's take a look at dividing a mixed number by a fraction. Let's jump into our example where we have 2 and 4/7 divided by 1/5. Now the first thing that we need to do is convert the mixed number to an improper fraction. That way we just have a numerator and a denominator, and we can go through our dividing fractions steps. Keep, switch, flip. So let's convert 2 and 4/7 to an improper fraction. So we start at the bottom, we multiply, and then add. So the denominator times the whole number, 7 times 2 is 14, and then add the numerator. 14 plus 4 is 18. That is our numerator of the improper fraction. And then we keep the denominator of 7 the same, divided by 1/5. So I rewrote the problem with the mixed number as an improper fraction. Now let's go through our steps. Keep, switch, flip. So keep 18/7, switch to multiplication, and then flip 1/5. So 5 is now the numerator, and 1 is now the denominator. Now we can multiply straight across. Let's start with the numerators. 18 times 5, that gives us 90. Now for the denominators. 7 times 1, that gives us 7. So we end up with 97ths, which is our answer, but it's an improper fraction. So let's convert it to a mixed number. We do that by dividing the numerator, 90, by the denominator, 7. So we have 90 divided by 7. So how many whole groups of 7 in 90? Well, let's work through this off to the side here. So 90 divided by 7. 9 divided by 7, we have 1. 1 whole group of 7 in 9. Multiply. 1 times 7 is 7. Subtract. 9 minus 7 is 2. Bring down. And now we repeat. So we divide. 20 divided by 7. How many whole groups of 7 in 20? Well, 2. 2 times 7 is 14. Subtract. 20 minus 14 gives us a remainder of 6. So 12 whole groups of 7 in 90. That's the whole number of our mixed number. And then we have a remainder of 6. We don't hit 90 exactly. That remainder is the numerator of the mixed number. And then we keep the denominator of 7 the same. So we end up with 12 and 6/7. We can always look to see if we can simplify the fractional part of a mixed number. 6/7 is in simplest form. The only common factor between 6 and 7 is 1, so we are done. 12 and 6/7. So there's how to divide a mixed number by a fraction. Let's move on to dividing a fraction by a mixed number. Now let's take a look at dividing a fraction by a mixed number. Let's jump into our example where we have 3/4 divided by 1 and 5/6. Now the first thing that we need to do is rewrite this problem with the mixed number written as an improper fraction. So we need to convert that mixed number to an improper fraction. That way we just have numerators and denominators and we can go through our steps, keep, switch, flip. So let's rewrite this problem. We have 3/4 divided by, and then as far as 1 and 5/6, let's convert this to an improper fraction. We start at the bottom and work our way up. We multiply and then add. So take the denominator and multiply it by the whole number. So 6 times 1 is 6, and then add the numerator. 6 plus 5 gives us 11. That's the numerator of the improper fraction. And then we keep the denominator of 6 the same. So now we have 3/4 divided by 11/6. Now let's go through our steps, keep, switch, flip. So keep 3/4. Switch to multiplication, and then flip 11/6. So 6 is now the numerator, and 11 is now the denominator. So we have 3/4 times 6/11. Now let's multiply straight across, starting with the numerators. So 3 times 6 is 18. Now for the denominators, 4 times 11 is 44. So we get 18/44, which is our answer, but we can simplify this fraction. We have a common factor other than 1 between 18 and 44. We have a greatest common factor of 2. So let's divide 18 by 2 and 44 by 2. 18 divided by 2 is 9. 44 divided by 2 is 22. So we end up with 9/22, or 9/22. The only common factor between 9 and 22 is 1, so this is in simplest form, and we are done. So there's how to divide a fraction by a mixed number. Let's move on to using cross cancellation when we have a division problem involving fractions. Now we will take a look at using cross cancellation when we have a division problem involving fractions. Cancellation gives us smaller numbers in value to work with and easier numbers to work with. This is a way to simplify the problem before multiplying. And remember, when we have a division problem involving fractions, we end up multiplying. Let's jump into number 1, where we have 4/9 divided by 8/15. We can't use cancellation quite yet. We can't use it right away. We use cancellation when multiplying fractions, so we need to wait until we go through the steps we use to divide fractions. Keep, switch, flip, or keep, change, flip. So let's keep the first fraction of 4/9, switch to multiplication, and then flip the second fraction of 8/15. So 15 is now the numerator, and 8 is now the denominator. Now we can multiply straight across, but before doing so, we can look to use cancellation. When we use cancellation, we look diagonally for common factors other than 1 that we can divide by. Think of this like simplifying fractions, but we are looking diagonally. So for number 1, we look at 4 and 8, and then 9 and 15. Let's look at 4 and 8 first. Are there any common factors other than 1 that we can divide 4 and 8 by? Yes. Let's use the greatest common factor of 4, so we can divide 4 and 8 by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. Now we can take a look at 9 and 15. Are there any common factors other than 1 that we can divide 9 and 15 by? Yes, 3 is a common factor between 9 and 15, and it's the greatest common factor. So let's divide 9 and 15 by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. Now we can multiply straight across, and we have smaller numbers in value to work with, easier numbers to work with. Let's start with the numerators. 1 times 5 is 5. Now for the denominators, 3 times 2 is 6. So we end up with 5/6. The greatest common factor between 5 and 6 is 1. So we are in simplest form, and this is our final simplified answer. Again, 5/6. Now let's work through that problem without using cancellation and see what happens. So keep, switch, flip. So keep 4/9, switch to multiplication, and then flip 8/15. So now we have 15/8. Let's multiply straight across. 4 times 15 is 60. 9 times 8 is 72. So we get 60/70 seconds. Now that's different than the answer above. That's because we haven't simplified yet. Are there any common factors between 60 and 72 other than 1? Yes. The greatest common factor between 60 and 72 is 12. So let's divide both of them by 12. 60 divided by 12 is 5. 72 divided by 12 is 6. So you can see that we get 5/6 that way as well. We get the same answer either way. Now, do we have to use cancellation? No, but it's a good strategy to be familiar with and use when possible. It can be helpful. Let's move on to number 2, where we have 12 divided by 6/7. Let's keep, switch, flip. So keep 12, and I'm going to write it in fractional form. That way we have a numerator and a denominator, and we can multiply straight across. Remember, we can rewrite any whole number in fractional form by putting it over 1. Then we can switch to multiplication and flip. So 7/6. Now we can multiply straight across, but before doing so, we can look to use cancellation. So let's look diagonally for common factors other than 1. Let's look at 12 and 6 first. Are there any common factors other than 1 that we can divide by? Yes, 6 is the greatest common factor between 12 and 6, so let's divide by 6. 12 divided by 6 is 2. 6 divided by 6 is 1. Now let's take a look at 1 and 7. Are there any common factors between 1 and 7 other than 1 that we can divide by? No, so we can't use cancellation going that way. So now we're ready to multiply straight across. Let's start with the numerators. 2 times 7 is 14. Now for the denominators, 1 times 1 is 1. So we end up with 14/1, which is 14. And that's our final answer. So there you have it. There's how to use cancellation when we have a division problem involving fractions. Now, can we use cancellation with every single problem? No. We have to have common factors other than 1 that we can divide by diagonally. And do we have to use cancellation in order to get to the correct answer? No, but it is a good strategy to be familiar with and it can be helpful. So there's how to use cross-cancellation when we have a division problem involving fractions. Let's move on to using cross-cancellation when dividing mixed numbers. Now we will take a look at using cross-cancellation when dividing mixed numbers. Let's jump into our example where we have 8 and 4/7 divided by 2 and 2/5. Now we use cross-cancellation when we get to the multiplying step, so keep that in mind. Now the first thing that we want to do is convert these mixed numbers to improper fractions. That way we just have a numerator and a denominator, and we can move forward with our steps. So we'll start with 8 and 4/7. We'll start at the bottom and work our way to the top. We multiply, then add. So we do our denominator times the whole number. 7 times 8 is 56 plus our numerator of 4. So 56 plus 4, that gives us 60. We keep our denominator of 7 the same. Let's bring our division sign down, then do the second mixed number here. So start at the bottom, multiply, then add. 5 times 2 is 10, plus 2 is 12. So we get 12/5. Now that we have our mixed numbers converted to improper fractions, we can go through our dividing fractions steps. Keep, switch, flip. Also known as keep, change, flip. There's different words out there for the steps, but they all mean the same thing. One thing I do want to mention before moving forward, these improper fractions are equivalent to the mixed numbers. So 60/7 is equivalent to 8 and 4/7. 12/5 is equivalent to 2 and 2/5. So when we convert to improper fractions, we're not changing the value of the problem at all. All right, let's go through our steps, keep, switch, flip. So we always keep the first fraction. So 60/7. Then we switch or change to multiplication, and then flip our second fraction. So the denominator becomes the numerator, and the numerator becomes the denominator. This is called the reciprocal. So we have 5/12. Now we can multiply straight across. But in this problem, we have an opportunity for cross-cancellation. Cross-cancellation is a way to simplify fractions before multiplying. It gives us smaller and easier numbers to work with, therefore a simpler problem to solve. We cross-cancel by looking for common factors between the numerators and denominators, so the top and bottom. Think of it like simplifying fractions, but we can look diagonally as well. For example, we have common factors other than 1 between 60 and 12, and a greatest common factor of 12. So let's divide 60 and 12 by 12. We do that by crossing them out and dividing by 12. So 60 divided by 12 is 5. 12 divided by 12 is 1. We can also look diagonally the other way. So we have 7 and 5. The only common factor between 7 and 5 is 1, so we can't use cross-cancellation with the 7 and the 5. Once we cross-cancel, we can multiply straight across. So we have 5 times 5, which is 25. And then we have 7 times 1, which is 7. So we get to 25/7. That's an improper fraction. Let's convert it to a mixed number. So we do that by doing the numerator, 25, divided by 7. So 25 divided by 7, let's think how many whole groups of 7 can we pull out of 25? Well, 3 whole groups of 7. That's our whole number. Now we do not hit 25 exactly. We have something left over, a remainder. So the difference between 25 and 21 is 4. That's our remainder. So that's our numerator. And then we keep our denominator of 7 the same. Always look to see if you can simplify the fractional part of a mixed number. 4/7 is in simplest form. So this is our final answer, 3 and 4/7. Now, do we have to use cross cancellation? No, we can multiply straight across and do 60 times 5 and 7 times 12, then go from there. But cross cancellation, again, gave us smaller and easier numbers to work with. It's a useful tool to use when looking at multiplication problems that involve fractions. And another thing I want to mention, cross cancellation can't be used with every problem. We have to have common factors other than 1 between our numerators and denominators that we can divide by. If the only common factor is 1, then cross cancellation cannot be used. So there's how to use cross cancellation when dividing mixed numbers. Let's move on to dividing improper fractions by improper fractions. Now we can take a look at dividing an improper fraction by an improper fraction. Now, when we have a division problem involving improper fractions, we go through the same steps we use when we have division problems involving proper fractions. Keep, switch, flip. So don't let a problem hold you up if it involves improper fractions. Again, just go through the same steps. Let's jump into our example where we have 8/3 divided by 11/5. So keep, switch, flip. So keep 8/3, switch to multiplication, and then flip 11/5. So 5 is now the numerator, and 11 is now the denominator. Now we can multiply straight across. Let's start with the numerators. 8 times 5 is 40. Now for the denominators, 3 times 11 is 33. So we end up with 40 over 33, or 40/33. Now that is our answer, but it's an improper fraction. So let's convert it to a mixed number by dividing the numerator 40 by the denominator 33. So how many whole groups of 33 in 40? Well, one whole group of 33 in 40. Now we don't hit 40 exactly. We have a remainder, and that remainder is 7. That's the numerator of the fractional part of the mixed number. And then we keep the denominator of 33 the same. Always look to see if you can simplify the fractional part of a mixed number. 7/33 is in simplest form. The only common factor between 7 and 33 is 1. So this is our final answer, 1 and 7/33. Now, just as a quick recap as far as how we went from that improper fraction of 40 over 33 to the mixed number of 1 and 7/33. I'm going to write it out. So again, we divided the numerator 40 by the denominator 33. So 40 divided by 33. How many whole groups of 33 in 40? Well, 1. 1 times 33 is 33. Subtract, and we get that remainder of 7. 1 is the whole number part of the mixed number, and then 7, the remainder, is the numerator of the fractional part. And then we keep the denominator of 33 the same. So there's how to divide an improper fraction by an improper fraction. Let's move on to dividing an improper fraction by a whole number. Now we will take a look at dividing an improper fraction by a whole number. Let's jump into our example where we have 10/4 divided by 9. So keep, switch, flip. Let's keep 10/4. Switch to multiplication, and then we need to flip that 9. Well, we flip that 9 by writing it in fractional form. And remember, we can write any whole number in fractional form by putting it over 1. And now we can flip it. So 1 is the numerator, and 9 is the denominator. So keep, switch, flip. And then we can multiply straight across now. We will start with the numerators. 10 times 1 is 10. Now for the denominators, 4 times 9 is 36. So we get 10/36, or 10 over 36, which is our final answer, but we can simplify. We have a common factor other than 1 between 10 and 36. There's a greatest common factor of 2. So let's divide 10 by 2 and 36 by 2 in order to simplify. 10 divided by 2 is 5. 36 divided by 2 is 18. The only common factor between 5 and 18 is 1. So this is in simplest form. Final simplified answer, 5/18. So there's how to divide an improper fraction by a whole number. Let's move on to dividing a whole number by an improper fraction. Now let's take a look at dividing a whole number by an improper fraction. Let's jump into our example where we have 8 divided by 15/8. So keep, switch, flip. Let's keep 8. And I'm going to write it in fractional form. That way we have a numerator and a denominator. And remember, we can write any whole number in fractional form by putting it over 1. So keep 8, and again, we wrote it in fractional form. Switch to multiplication, and then flip 15/8. So 8 is now the numerator, and 15 is now the denominator. Now we can multiply straight across. Let's start with the numerators. 8 times 8 is 64. Now for the denominators, 1 times 15 is 15. So we get 64/15. And that is our answer, but it's an improper fraction. So let's convert it to a mixed number by dividing the numerator, 64, by the denominator, 15. So 64 divided by 15. How many whole groups of 15 in 64? Well, 4 whole groups. That gets us to 60. We don't hit 64 exactly. We have a remainder of 4. That's the numerator of the fractional part of the mixed number. And then we keep the denominator of 15 the same. We can always look to see if we can simplify the fractional part of a mixed number. 4/15 is in simplest form. The only common factor between 4 and 15 is 1. So final answer, 4 and 4/15. Now, just as a quick recap, as far as how we went from that improper fraction, 64/15, to the mixed number of 4 and 4/15, I'm going to write that out off to the side. So we did the numerator, 64, divided by the denominator, 15. So we have 64 divided by 15. How many whole groups of 15 in 64? Well, 4. That's the whole number of our mixed number. Now we multiply. 4 times 15 is 60. Subtract 64 minus 60 gives us 4. So we have 4, remainder 4. That remainder is the numerator of the fractional part of the mixed number. And then we keep the denominator of 15 the same. So there's how to divide a whole number by an improper fraction. Let's move on to taking a look at why we use keep, switch, flip when we have division problems involving fractions. Now we will take a look at why we use keep, switch, flip when we have division problems involving fractions. You may also hear keep, change, flip, or multiply by the reciprocal. These all mean the same thing. Now, before we get into our dividing fractions example, we need to review and fully understand a few things about fractions. We'll start with fractions representing division. A division problem can be set up as a fraction. So for number 1, we have 8 divided by 4 equals 2. Now we can set that up as a fraction. We can set it up as 8 divided by 4 equals 2. So again, we need to know that fractions represent division. The second thing that we need to understand is that anything over 1, so a denominator of 1, equals itself. For example, 5 over 1 equals 5. So again, anything over 1 equals itself. On to number 3 here, we have fractions that have the same numerator and denominator. For example, 7 over 7, 7 sevenths. Anytime the numerator and denominator are the same, that fraction represents 1 whole. So 7 sevenths or 7 over 7, this equals 1. Again, same numerator, same denominator, equals 1. The fourth thing that we need to understand, equivalent fractions. Now remember, in order to keep a fraction equivalent, whatever we do to the bottom, we must do to the top, or vice versa. And we can use multiplication or division. This will give us an equivalent fraction. For example, 3/4 equals how many eighths? Well, we know that 4 times 2 equals 8. 4 times 2 equals 8. Now, whatever we do to the bottom, we must do to the top in order to keep this equivalent. So 3 times 2 gives us 6. So 3/4 is equivalent to 6/8. Both of these fractions have the same value. So we need to understand equivalent fractions. Lastly, number 5 here, we have reciprocals, which is flipping a fraction. So the reciprocal of 4 sevenths is 7/4. So this is the reciprocal of 4 sevenths. Now I'm multiplying 4 sevenths by its reciprocal, 7/4, to show that we get 1 whenever we multiply a fraction by its reciprocal. So 4 sevenths times 7/4, well, multiply straight across. 4 times 7 is 28. Now let's multiply the denominators, the bottom numbers. 7 times 4 is 28. So we end up with 28 28ths. And we know that if we have the same number on top, the numerator, as we do the bottom, the denominator, this is going to equal 1 whole, or 1. So reciprocals are the last thing that we need to understand. And again, a reciprocal, we flip the fraction. The numerator becomes the denominator, and the denominator becomes the numerator. And when we multiply a fraction by its reciprocal, we get 1. Now we are ready to see why we keep, switch, flip, or maybe you refer to it as keep, change, flip, or multiply by the reciprocal. Remember, all of those things mean the same thing. Let's use 3/5 divided by 1/4 for our example here. We know that we can set up a division problem as a fraction. Fractions represent division. So let's set up 3/5 divided by 1/4 as a fraction. We get 3/5 over 1/4. This gives us a fraction over a fraction. So 2 fractions making up 1 fraction. This is called a complex fraction. A complex fraction is a fraction where the numerator, denominator, or both are a fraction. Now, once we have our complex fraction, we want to get our denominator to equal 1. We know that anything over 1 equals itself, and that is going to make this much more manageable. Well, how do we get our denominator to equal 1? We need to multiply it by its reciprocal, flip the fraction. So let's multiply 1/4 by 4 over 1. And again, we are doing this so we get that denominator to equal 1, because we know that anything over 1 equals itself. Now, since we are multiplying our denominator by 4 over 1, remember, in order to keep a fraction equivalent, whatever we do to the bottom, we must do to the top, or vice versa. This keeps everything equivalent. The value doesn't change. So we need to multiply our numerator by 4 over 1 as well. So this is going to give us, well, 1 times 4 is 4. 4 times 1 is 4. Remember, when we multiply fractions, we multiply straight across. So again, 1 times 4 is 4, and then 4 times 1 is 4. Let's do our numerator. So 3 times 4, right here, is going to give us 12. And then 5 times 1 is going to give us 5. So we have 12/5 over 4/4. Now we know that when we have the same numerator and denominator, the fraction equals 1. So let's rewrite this as 12/5 over 1. This is our new complex fraction. It's equivalent to what we started with, but now we have a denominator of 1, and we know that anything over 1 just equals itself. So our answer is 12/5. Now, 12/5 is an improper fraction, so we want to change this to a mixed number. We do that by dividing our numerator by the denominator, so 12 divided by 5. How many whole groups of 5 can we pull out of 12? Well, 2. Now, that doesn't hit 12 exactly. We have a remainder of 2, and we keep our denominator of 5 the same. Now, 2 2/5, our fractional part, is in simplest form, so we are done. 2 2/5 is our answer for 3/5 divided by 1/4. So you can see that that was a fairly long process. That's the long way of dividing fractions. It does work, but we can use keep, switch, flip to be more efficient. Let's try keep, switch, flip as well and see how everything compares. So I'm going to rewrite the problem at the bottom of the screen here. So we have 3/5 divided by 1/4. So let's keep, switch, flip. So keep our first fraction, 3/5, switch to multiplication, and then flip our second fraction. We get 4 over 1. And then we multiply straight across. We get 12/5, the same answer we got when we used the long way. And we convert this to a mixed number, which is 2 2/5. So you can see, look up here, and you'll notice that we have 3/5 times 4 over 1. The same thing we have down here. Now, keep, switch, flip, again, is a much quicker process here. We're always going to end up with the same thing here and here. So why not cut out all of the extra parts of that process and just jump straight to keep, switch, flip? So there you have it. There is a complete guide to multiplying and dividing fractions. I hope that helped. Thanks so much for watching. Until next time, peace.